Hey there, and welcome to This Explainer. Are you ready to have your perspective completely shifted by just a beautifully simple thought experiment? Today, we're diving into a scenario featuring one of the most genuinely counterintuitive mathematical facts you're going to encounter all week. It's this wild concept that literally pits your everyday common sense directly against the inescapable elegance of math.
Part 1, the Earth Rope Riddle. Let's set the stage by dropping you right into the middle of this massive planetary puzzle. I want you to just take a second, clear your mind, and really visualize the vast, awe-inspiring scale of our planet. Picture the continents, those deep oceans, and just the sheer, unbelievable distance all the way around the equator.
So, I'm going to propose a scenario to you, and I really want you to lock in your guess before we reveal the answer. Seriously, don't just passively listen to this one. Commit to a number in your head. Let's see exactly how well your human intuition holds up against cold, hard geometry. Okay, here's the setup. Step 1, imagine you wrap a rope tightly around the entire circumference of the Earth, like it's completely snug against the ground, making this perfect loop all the way around the globe, right? Okay, now step 2, you decide you want to lift that rope exactly 1 foot off the ground, all the way around the entire planet. Every single point of that massive rope is raised into the air by exactly 1 foot. So, here's the big question. How much extra length has to be added to that original loop of rope to make this massive planetary lift actually happen?
Part 2, the intuitive guess. Let's talk about our common sense expectations here. When you think about the staggering, literally immense size of our planet, well, let's explore what our gut tells us. The Earth's circumference is so vast that our brains naturally just kind of want to scale up the solution to match the sheer size of the problem. When you're picturing that huge circumference of the Earth stretching on and on, you might easily think that you'd need miles and miles of extra rope just to raise that whole loop by a single foot. And honestly, that feels entirely logical, doesn't it? I mean, if the object you're wrapping is gigantic, then the amount of slack you need to pull it away from the surface should be equally gigantic.
But here we are at part 3, the real answer, math versus intuition. Okay, let's actually dive in and look at the mathematical reality here, because you better prepare to have that logical guess you just locked in thrown completely out the window.
In reality, you only need 2 pi, or about 6.3 feet of extra rope. I know, no way, right? It sounds totally impossible, but here's the beautiful, simple math behind it. Think back to your basic high school geometry. The formula for any circle circumference is 2 times pi times the radius. So when the rope is snug on the ground, its length is exactly 2 times pi times the Earth's radius. Now, when you lift that rope 1 foot off the ground, the new radius just becomes the Earth's radius plus 1. If we plug that into our little formula, the new circumference is 2 times pi times that new combined number. And when you expand that out algebraically, you just get the original circumference plus 2 times pi. The starting size of the Earth literally cancels out completely. The exact difference between the snug rope and the lifted rope is simply 2 times pi. So you need just 6.28 feet, a little over 6 feet, of extra rope for the whole shebang.
Which brings us to part 4, the universal rule. Any sphere works. Because you see, the wild nature of this mathematical truth doesn't just stop with the Earth.
And this brilliantly illustrates our final twist. Whether you're wrapping a rope around the immense, fiery circumference of the sun, or the massive Earth, or a standard basketball, or actually even a tiny little marble sitting right there on your desk, every single one of them needs the exact same 6.3 feet of extra rope to be raised by 1 foot. So, the absolutely crucial takeaway from this explainer is that this mathematical rule is always the case. Regardless of the radius, the starting size simply does not matter at all. And, it leaves us with a pretty fascinating thought to ponder today. If our human brains can be this incredibly wrong about something as simple as a rope and a sphere, what other basic common sense assumptions is mathematics just waiting to completely turn upside down?